Okay, we know that there are 4 methods of proving triangles congruent. We have side, side, side. Side, side, side. Little help. Side, angle, side. Angle, side, angle. Angle, angle, side. Got it. Okay. Even though still had people put angle, angle, angle yesterday. And side, side, angle yesterday. This is not side, side, angle. All right, this is not side, side, angle. This is used when the angle's in between. If it's not in between, I just say they're not congruent. All right, we'll get there sooner or later. We'll get there. And also, third angles theorem, not a way to prove triangles congruent. Okay, third angles theorem, not a way to prove triangles congruent. Right, here are the only 4 ways, and I'm about to go over a 5th way, which is called HL. It stands for the following: hypotenuse for the H, and leg for the L. Hypotenuse, leg. Where is a hypotenuse only located? In what type of triangle? Only in a right triangle, which means what about this method? It can only be used in a right triangle, yes. All right, if it's not a right triangle, I'm going back to these 4 methods right here. All right, it has to be used in a right triangle, okay? And this is why I have the note here. If you are going to use hypotenuse leg in a proof, you have to tell me somewhere in your statements that you have right triangles. Okay, you have right triangles, right? If you use HL in the proof, which we'll do a bunch. We're going to do 4 proofs today that involve HL. Okay, next thing before we start a proof is, where is the hypotenuse located? Because usually I say hypotenuse, you guys respond longest side, longest side, longest side, which is true. But I never label my sides with any lengths in a proof. You've never seen that. I've never said this side's 8 inches in a proof. So how else can you identify where the hypotenuse is in a right triangle, other than it's the longest side? Because you're not going to know which one's the longest side, because I'm not going to mark it the longest side. So how else can you find the hypotenuse in a right triangle? Mike?
Is it like across from the right angle?
Done. Say it again for everybody. It's across from the right angle. All right, the hypotenuse will always be located directly across from your right angle. That's how you can locate it. The other sides are called the legs. Okay? You need a pair of hypotenuse congruent and a pair of legs congruent. That is hypotenuse leg. And it doesn't matter which pair of legs. No, it does not. All right, but you have to have the hypotenuse in there too. Questions about HL right now before we apply it? Hypotenuse leg can only be used in a right triangle. All right, let's go. I already wrote the givens in there for you. So we're together very, very slowly on this first one. We're going to mark our diagram up. So ABC is a right angle. DCB is a right angle. Go ahead, mark those on your diagram right now as right angles, please. ABC and DCB. So we have a right angle here and a right angle here. And then AC is congruent to DB. Everyone agrees I have right triangles? So now what I want to say is, all right, is there anything else you can mark on that diagram yourself that's not given? What else can I mark on my diagram that I'm always allowed to do that's never given? Okay. What else can I mark on here? Go ahead, Emma. Where? On CB. That side is shared by CB. So now let's take a look at what we have. All right, I know it's HL day, so it's probably going to be HL, but why can I eliminate some other ones? Well, why isn't this side angle side? I have 2 sides and an angle. Why isn't it side angle side? You. That angle is not in between those 2 sides. Side angle side is out of the question here. Side, side angle, not even away, so don't even think about it. But it is a right triangle. Ready? What are these sides acting as? What did Mike just talk about? What are those sides acting as? Those are my Ooh, hypotenuses. What do you got for me? But I don't even know. Hypotenuses. It's like, what's the cap? What's the, what about rhinoceros? How do you say two rhinoceros, right? Rhinos. All right, here we go. So yes, these are my hypotenuse. And then what's CB acting as? My CB, I know it's a side, but in HL, what is it? It's the leg. So does everyone see HL being applied here? It's a right triangle. I got the hypotenuse and I got the leg. So it's HL. So what do I need to put in my proof now? Bunch of things. And this is also, hey, by the way, where some of you guys just need to improve slightly is on yesterday's quiz, I saw a lot of people mark their diagram 100% correct, but some of it did get in here. This is where you make your money. This is what's graded. Okay, I don't grade your diagram, all right? Information forgot to get put in your statements reasons. So what else do I need here? What else do I need? Can I go back here maybe? Nope. Okay, here, we'll do it a different way. I always have a backup. Emily, ready? What else do I need? CB is congruent to CB. And my backup, Emily, is you guys decide. Need somebody else now. Don't care who. Okay, Rachel, I got CB congruent to CB. I can't say the triangles are congruent yet by HL. I still need something else. Okay, let's talk about that right now. Can I say right angles are congruent? Yes, you can. That is a correct statement that you added in. But here's the little catch for today. What's the name of this method? Hypotenuse leg. So all you need are the hypotenuse and the leg. I don't need to know if any angles are congruent. All right, because it's HL. Is there a letter A in there at all? No. So can you put the right angles congruent? Sure, go ahead. It's an extra step, just not needed for HL. Does everyone see why I don't need to say the right angles are congruent? Okay, the angles aren't involved. But I do need to say they're what type of triangles, though? Right triangles. Yes, that's an absolute before I say HL. So I need to say triangle ABC and triangle DCB are right triangles. First time, yes? If you've decided to use side, angle, side, anything with an angle, then yes, I would need to say the right angles are congruent. All right, well, why are they right triangles? Because they have? All right, so right triangles, here's our reason. Right triangles have right angles. There it is. Short and sweet. And you better have stated you have what before you write this then? You better have right angles before you state this. And yes, it was given. Sometimes you may have to write it in coming up in the next proof. Okay, so I got, let's just take some inventory here. I have the hypotenuse, I have the leg, and I said the right triangles. We're good to go. All right, we are now good to go to say the triangles are congruent. Triangle ABC, congruent to triangle DCB, HL. Okay. Any questions on this base HL proof? Mike, go.
So you don't need both legs?
No. If I had both legs, isn't that side, angle, side? Right? Or if I had all three, that would be side, side, side. Okay? So no, I don't. I just need one. Other questions? All right, let's keep going here. Here's the basic proof. We're just going to keep increasing in difficulty here today. I'll let you mark your diagram, and then we'll discuss C, D, E, A, and then Rachel, going to need somebody for my next question. Okay, Laura, ready? Forget about the givens. I'm going right to the proof statement, everyone. Proving AB congruent to BD. So if I'm going to prove segments congruent, I can't do that unless what? I have congruent. Well, I can't. What did we do the other day? I can't prove segments congruent until the what are congruent? Okay, how am I going to get these congruent? How did what's today? Thursday? Tuesday. And then we'll say, see, we know how this is going to end. This is going to end by saying what? CPCTC. But I can't do that unless, Laura, the triangles have to be congruent. All right, the triangles have to be congruent. All right, how am I going to get the triangles congruent? Everyone ready? Need somebody. I need somebody new here. Okay, here we go, Kate. I already marked CD congruent to AE. AD is a perpendicular bisector of CD. Let's take care of the perpendicular part. What's going to happen when AD and CE meet? They're going to create right angles, so let's put them in our diagram because they're perpendicular to each other. Need somebody else, Kate? Whoa, 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 I'm not there yet. What is getting bisected? Line segment CE is getting cut in half, which means what two line segments are congruent, Hugh? Okay, you just told me CE is being cut in half, and you gave me two different line segments. CB and BE, yep. Do we see that? BE is being bisected. It's being cut into two congruent parts. Does everybody see? Hey, side angle side, anybody? Is the right angle in between? Nope, but it is a right triangle. What are these acting as? CD and AE. Those are my hypotenuse, right? And what are CB and BE acting as? My leg. So this is a case of HL. All right, diagram's beautiful, but got to put it into the proof. So Hugh, call on somebody. Here we go. Anything now, Mike, you want to give me? Something that's in our diagram that we have yet to write down. Angle EBA and angle CBD are right angles. How do we know that, Mike? Yep. I would also accept if you guys put definition of a perpendicular bisector, perpendicular line, that's fine too. Okay, I got right angles now. Got it. Next up, Mike.
Choose someone?
Yep.
Will. CB is congruent to BE.
CB is congruent to BE. Why, Will? Yep. Or perpendicular bisector, I'd accept that. And that gives us, what did we call CB and BE? Are those the hypotenuse or the legs? Those are the legs, yep. So it looks like I have HL, except I can't write HL yet. Will, need somebody. I can't say HL yet until I tell you I'm working with. I have right angles. I can only use HL if I have. I can't use HL unless I have right triangles. So what do you want to tell me here? Okay, so what would be my statement? Triangle. And
Triangle ABC.
R.
Right triangle.
Yep. And how do you know that?
Because right triangles have right.
Yep.
Why would it be ABD instead of ABE?
ABE.
Why wouldn't it be triangle ABE?
I don't know why I put ABD. So let's, which was just about to get into my next point, which is I don't care how you name the triangles until you tell me they're congruent. You know how we always match up the sides and angles when you write the congruent statement? That's the only time I care. I don't care how you label your triangles here in what order you do it in, as long as at the end the congruent statement is in the right order. That's the only time I care. Okay? So it looks like anything else we're missing? We got the hypotenuse, we got the legs. We told you they're right triangles. We're all set to go now. Go ahead, Sean. Need somebody. Correct congruent statement in a correct order. CBD congruent to EBA. That looks good to me. HL. Somebody else there, Max? Okay. Now why are those two segments congruent, Nick? And in the correct order. Nice job. CPCTC. So we did one using HL. We did one using HL, then CPCTC. We are going to take it up a notch, skip the next one because the next one you're going to do with your group and somebody's going to come up and present it. So make sure you are on example 4 right now. Example 4. We back in business. No. All right. Before you do anything, stop. Everybody just stop. What is brand new about this proof? What is something that makes you feel uncomfortable? What is something we've never seen before right now? Emma, what have we never seen before? Yeah, we've never seen this proof statement before. We can prove segments congruent. We can prove angles congruent. We can prove triangles congruent. But never have we seen something proving something bisects an angle. Never. Okay? It's not going to be an issue, though. Here's what I want from you guys right now. What if I gave you that? What if I put that fact into the givens? What would you say as a conclusion? If I told you, hey, AB bisects angle DAC, you would tell me, oh, this is true. What would you tell me is true? Go ahead, Emma. Keep on rolling. Is there something in the water with this class? Why do you guys always want to tell me segments are congruent when an angle is being bisected? Yes? Because that's like the 50th time it's happened in here. What's being bisected? An angle, right? So you should give me two angles that are congruent back, right? Go ahead, Mike. Angle DAB is congruent to angle BAC. Ready? If that's true, that'll be true. So guess what I'm going to turn this proof into? Get me these two angles congruent. Okay, then I'll show you how to make AB a bisector. All right, but first thing you guys have to do, get me the angles congruent. Who is the... Nick, need somebody. Okay. Well, Justin, right? The angles aren't going to be congruent unless the what are congruent. All right, let's get the triangles congruent then. So go ahead, get your givens in, everybody. Mark your diagram appropriately. So triangles, angles, and then we'll talk bisector. That's our goal right now. Oh, we're back in business. Okay, I'll try to take a more hands-off approach here and just let you guys take over. I marked my diagram with BD and BC, but I didn't mark anything else because I want you to tell me. All right, so what else can I write now? Here we go, 14. What else can I write? Thank you. Your classmates are like, oh, it's the one I wanted. And I'll get to that in a second because we're not ready to label it yet. So I got BA, shared. Got it. Okay, more now, more. Here we go, 5, more.
Angle ACB, angle ADB are right.
Thank you. Angle ACB and angle ADB, right angles. Why, Mike? Okay, here's what I wanted to ask now. And I'm going to ask it to number 1. Cameron, here we go. Ready? Now that we have the right angles in here, what is BD and BC? Are those the legs, the hypotenusae? Those are the legs, yep. And what are BA and BA? Those would be the hypotenusae, hypotenuses, yes. So you got the hypotenusae, you got the legs. Need something else, though, before I can say they're congruent. Need a little something else. 12. There you go. Got to tell me these bad boys are right triangles. So triangle ACB and triangle ADB are right triangles. Again, I don't care what the order of the letters are. Not until you tell me they're congruent. Why? Right triangles have right angles. We're getting there. We're getting there. Now the triangles are congruent by hypotenuse leg, but I'm going to need a good congruent statement here. What do you got for me? Congruent statement. 19. DBA congruent to CBA. Let's take a quick glance here. DBA, CBA, fine. No issues. Okay, now the triangles are congruent. I now know which pair of corresponding parts. 11. Yep. We call DAB and BAC. Why? There we go. Yep.
Do you have to put them all in that exact order? Like, you need to know that.
The only thing that has to come before is saying the right angles has to come before the right triangles.
But you could put, like, reflexive after.
I could have put reflexive right after I said the right triangles. I don't care. Yep. The order doesn't matter. The only order that does matter, like I said, is you need right angles before you say they're right triangles. Okay, now that I know those two angles are congruent, what do I know about AB? It bisects DAC. We just have to come up with a good reason now. So AB bisects angle, what was it? DAC, yep. Okay, most of you, I would not blame you if you just wrote definition of a bisector. But that's not going to cut it because, again, let me do my classic example. Emily's like, hey, I'm sitting in a chair. Well, why are you sitting in a chair, Emily? Well, that's the definition of a chair. That doesn't tell us anything at all, right? So I don't want to say definition of a bisector. What have we already done and wrote down that we know AB is a bisector? What fact have we already written down up here that says AB must be a bisector? Will? So you know what I'm going to write? DAB. It's a bisector because DAB is congruent to BAC. All right, that's what makes it a bisector. So a little bit different type of proof, but no big, we still prove triangles congruent. Got a pair of angles congruent by CPCTC to show this fact right here. Okay, for this last one, you and your group are on your own. And then whatever number comes up, that person and their group will come up and fill in the proof for me. Now, before you start, notice there's multiple triangles in this diagram, correct? Well, which ones do I prove congruent? What did we say the other day? Prove the ones that contain the proof statement. So prove the ones that contain angle 1 and angle 2. Good luck. Get after it. Okay, take a look. I don't care the order of the steps. Making sure you got reflexive in there. EF is congruent to itself. Then you use subtraction. A The only thing up here is make sure, right here, we want that switched, right? BF minus EF, okay? Yep, and then DE minus EF, substitution. Right triangles have right angles, which they've already stated in step 2. Anything you want to add on? Because there's one other thing I want to go over, which is a common mistake here. And this proof's fine, no big deal. Questions? Here's what I usually see, and I want to make sure you guys avoid this, is when you're using subtraction or addition, doesn't matter. Here's what I usually get. BD is equal to BD, so they take the full line segment here, BD, and they say EF equals EF, and they try to subtract those. BD minus EF equals BD minus EF, and they say by substitution, you take EF out and you get BE and FD. Okay? No. Watch why that is totally incorrect. Cameron, give me just a random length for BD. 7. Fine. Sean, give me a random length for EF. Well, that's not going to work because EF is a little shorter than BD, but it's okay. So how about something less than 7? You were. I'm not. 2. Okay. So here it is. If BD is 7, EF is 2, I take away that, how much is left? 5. Everyone agrees? I have 5. Is that necessarily saying that's 2.5 and that's 2.5? No, it could be. Oh, now everything's not working after that comment. It could easily be what? 4 and 1. Could easily be 3 and 2. What I'm trying to get to you guys, you cannot subtract 2 reflexive quantities. Okay? Please don't try to subtract 2 reflexive quantities. And I know this sounds silly that I have to mention it, but it happened in my 8th period class the other day. You cannot subtract triangles from each other. Okay? Triangle ABC minus triangle DEF, that doesn't fly. You can only subtract segments and angles from each other. Okay? All good? You don't even have that many for tonight, I believe. And I think there's only one that they're not proofs. Only one of them's proof, number 14. And that's it. Okay? So get after it, please.